Okay, so again with this topic we've got the organic section of the course, and we're looking at the propagation step in the chlorination of methane. So this is all to do with the 3 radical substitution reaction, which is different completely to most of the mechanisms that we actually look at in the rest of the year 12 mechanisms and the rest of the year 13 mechanisms too, in that this involves the homolytic fission. Homo meaning same, fission meaning to split. We're talking about the bond. So we're at the idea that this chlorine-chlorine bond will use the single-headed arrow and the single-headed arrow to form what we call free radicals, 2 free radicals, which are very, very reactive species, and they contain an unpaired electron. Now, this reaction mechanism is a little bit weird in the sense that it has 3 different stages. It has the initiation stage, which means to start the reaction, number 1. The second stage is the propagation, which is what this question is referring to. So to propagate something means to continue it on. Okay. And third, it also has termination. So termination means to end. So the termination of something means to cut it short, to end it. So to continue and to end is how we want to be thinking about things. But what I want you to pay attention for this particular question, I'll show you some examples. So I'll put an example of the propagation step here. We take the chlorine radical, we'd react it with the CH4 methane, and it would make the CH3 radical and our HCl that we could see in the overall equation. There's 2 sections to this though, so we've got the A reaction and the B reaction. So this time now we'll take the methyl radical, react it with another molecule of chlorine, and it will form our product, CH3Cl, chloromethane, and we'll also get another radical. An example of a termination could be written like this. So you take 2 of the radicals from above that you can see, and for example you'd say C2H6. But I want you to pay attention to the number of radicals in each step and which side they're on. So splitting the reaction down the middle, reactants and products. For initiation, you always see that there's no free radicals in the reactants and 2 free radicals in the products. These 2. For the propagation steps, you always see that there's 1 free radical in the reactants and also 1 free radical in the products. So this is interesting because obviously the free radical needs to be produced for it to continue on to go on to the next stage and react with something else. In a termination, you'd see 2 free radicals and 0 free radicals in the products. So first off, we can eliminate some of these based on the fact that they don't, like this one for example, has 2 free radicals in the reactants and no free. This is a termination step. This is not a propagation step. Now the others that we're looking at are going to involve which species are correct. And what they really like you to know is that this does not exist. H radical never ever forms. You never see this H radical. So if it's appearing in both of these propagation steps, even though they have 1 free radical on each side, the reactants and the products, which is our rules, that it doesn't exist the H radical, so therefore this is going to be the wrong answers, A and B. So this must be the correct one, D, which we can see here.